Okay, so we start the next chapter. The topic is logarithms. It is a very important topic. You will need it even in the science, not only just in math. But let me motivate you and then immediately start talking about the topic. Okay, so let me start with a very simple motivating example. If I give you this equation, for example, I say 2 to the power of x, x is not known, the answer is supposed to be 4. Of course, you immediately answer the question, x is equal to 2. Yes? Exactly like that, if I ask you this question, x to the power of 2 is 16, you can answer this question to be two numbers, yes? Here plus or minus 4. But there is a difference between this equation and that equation. In this equation, what is unknown is in the base, and the number 2 exponent is known to you, it's 2. But this problem is the other way around. Yes, the problem here, what you don't know appears in the exponent, what you know appears in the base. But still, it was not hard. You can immediately answer this one and answer this question. But if I change this problem to 2 to the power of x to be 5, then you will to be in trouble a little bit here. Exactly like this, if I write x to the power of 2 is equal to 15, in principle, if you haven't started learning about the square root signs, you were in trouble. The reason that this is not a big problem for you now is because you know square root, yes? So what if I ask you what the answer is, you write x is plus or minus a square root of 15. In the same way, if I ask you what square root of 15 is, one thing you can do is to put it in the calculator and find an approximation for a square root of 15, but that's not the exact answer. That's an approximate answer. So what is the answer? If someone asks you what square root of 15 is, there's only one way to answer that person, and that is to tell square root of 15 is the only positive number whose second power is 15. Yes? So I want you to feel, because you will feel the same thing in this new lesson. If I write x squared is 15 and answer x is plus or minus a square 15, you are happy and you don't ask question, because mainly not because you really understand what's the square root of 15, because you got used to it. But if I want to ask the deeper question, what square root of 15 is, you can answer this question in two different levels. One, approximation level. You can say that, okay, I take my calculator and punch a square root of 15 in the calculator. I see a number appears in my display. Then I would say that number is the square root of 15, but you already know that if you have a bigger display, then you will have more digits appear. And if you have an even bigger display, you will have more digits appearing. So what you saw in the small calculator is not exactly square root of 15, because if it was, if it were the exact value, by increasing the level, the size of the display, you shouldn't get a new number. So, but I want you to understand, a square root of 15 at the level of approximation and practical level is the same number that appears on your display, roughly speaking. But from mathematical point of view, what is the exact definition of a square root of 15? You would say that square root of 15 is the only positive number whose square is 15. Yes? How should I know that such a number exists? But let me tell you a little bit about graphs. This function y equals to x squared, you already know this is this number. This is something similar to this, and it is a continuous curve. Because I want to work with positive values of x, so if you don't mind, let me ignore this branch which is related to the negative x's. Okay, I only concentrate on one part of this graph. So if I give you 4 here, how can I find the number? So this is y equals to x squared. So how can I find, yeah, b side? Okay, so how should I find the number whose square is this? Yes? Yes, exactly. This is what I want to take with me to this new problem. Of course, the problem was so simple, you did it in your head, but let us say that I want to solve it graphically. So I want to know so this is the function y equals to x squared. The output is supposed to be 16. Okay, so what should I do? I want to find the number. I go horizontally. When I intersect the graph, I go vertically down. This number is what? 4. Yes? Because this is y equals to x squared. If x is 4, y becomes 16. But if I do the same thing for 15, I can do something like that. I can go horizontally. When I intersect the graph, I go vertically down. What I get here is not as big as 4, but it is a number smaller than 4. That number is denoted by which symbol? The square root of 15. So even though I don't know the exact value of a square root of 15, I can imagine where square root of 15 is. If I have the graph of the function, I reverse engineer and I find the point. That point represents the square root of 15. So in the same spirit, I want to answer this question. But of course, you haven't studied the graph of these kinds of functions, but you need to trust me on that. We can also use GeoGebra to draw the graph. So I will first draw this graph, y equals to 2 to the power of x. So what I should do, yes. So what should I do? I draw the graph, but trust me on that. We can use GeoGebra later. So if you draw the graph of this, it is something like this. Okay, first of all, I want to test your understanding a little bit. Can you tell me what number is here? Sorry, that is not 2x.
1.
2 to the x.
1.
I didn't tell you why the graph looks like this, but trust me on that. Let us say this is the graph, but you should be able to tell me this. As you said, it is 1. Why?
Because when x is 0.
Yes, because here x is 0, and I want to know what is the y value if x is 0. If x is 0, 2 to the x, it becomes 2 to the 0. 2 to the 0 is y. So you get some graph like this. And if I want to ask this question, what is x if 2x is 4? I do the same process. I will go and find my 4 here. For example, let us say this is 4. What do? I go horizontally, and then when I intersect, I go backward vertically, and then I get a point. In this case, you know what that number is. What that number is? 2. Why? Because 2 to the power of 2 is 4. Yes? But now, if I do the same thing here, I go to 5, for example. This is 5. And I do the same thing. Definitely, you will get a point. But if I ask you, do you know exact value of this point? You would say no. This number, exactly like this. You remember I told you we symbolize this point by this symbol. Okay? The symbol we use to symbolize this point is a little bit more complicated. It is log, okay, of 4, 5 to the base 2. So this is a little bit strange, but that is a symbol. You don't be distracted, you know. You expect these two should appear, yes? So here, do you remember when I say a square root of 15, what numbers are involved? 15 is involved. There is another number involved that you don't see because there is a convention there, yes?
Power of 0.5.
No, I mean, in this symbol, there is also a number, yes?
2.
Where is 2? Yes, here. Whenever 2 is there, we don't write it. So you see, square root of 15 means the second root of 15. So this symbol that I used, putting 15 below it and 2 there, represents the only positive number whose second power is 15. In the same spirit, we are not using a math symbol, we are using a letter log to denote this number. So when this is the graph of 2 to the x, any number that you see on the vertical axis, if you go horizontally and go back vertically, what you get is a number so that when you put it back in this function, it gives you 5. Yes? That number is written as logarithm of this 5, which is 5 is this number, to the base 2. What is 2? 2 is the base here. Yes or no?
Yes.
So that is the number. But you might ask me, Babak, what is this number? I don't know. Exactly like if you ask me what is the square root of 15, I cannot answer. I can use my calculator to answer. So if you ask me what is this number, if you want, I can teach you how to put it in the calculator. You get a number. That number is an approximation to this number. Yes. Sometimes exactly like this. Instead of 4, I can write the square root of 16, but the square root of 16 is one of those exceptions that I can find the value exactly, which is in this case 4. In this case, can you tell me what can I write for 2 in the same spirit? I can write it as log. What should I put in front? 2 is coming from 4, so I put 4 in front. And what should I do in the base? The same base there, 2. But log of 4 to the base 2 turns out to be which value? 2. But this one turns out to be some value. It's a little bit larger than 2, but exactly what value I don't know. So I have to symbolize it by a strange symbol, log of 5 to the base 2. That's a logarithm of 5 to the base 2. Is that understandable? Okay, but how many of these functions I have? I have infinitely many. For example, I can ask you this question. X to power 3 is equal to, I don't know, 8. Of course, you can answer the question immediately. What is that? That is 2. But in the same way, if I want to use the graph to answer this, I only consider the positive one. The graph of this function, x to the power of 3, is something like this. Okay? But now I want to solve it graphically. What do? I go to 8 and then go horizontally. When I cut this graph, I go backwards and then I get a number. This number in this case is how much? Is 2, because 2 to the power of 3 is 8. But if I give you 9, and if you do the same thing, you go here, you go backward, of course you get a number. But that number is not something that you can come up with it exactly from your head, you know. You cannot know which number is that, whose third power is 9, but you can show it to me. Yes, this is that number. That number is represented by which symbol in mathematics? Still use the third sign. What do I put below? 9. But in this case, what do I put above? 3. Because the second root is very popular, we have the convention, don't write it if it is 2. But if you write it, it is not wrong. So that is the same. This is the third root of 9. So again, I want to tell you that I don't know the exact value. If I want to find the exact value, but let me ask you one question. What is the meaning of the third root of 9? The third root of 9 is the number whose third power is 9. So now, can you tell me what is the third power of third root of 9? 9. Why? Because you just told me the third root of 9 is that number whose third power is 9. And I am now raising it to the third power. So it becomes 9. Agree or not? Okay, now let us go back to this. I want you to understand that. 2, so logarithm of 5 to the base 2 is the number so that when you raise 2 to that number, it becomes 5. Yes, that is the number that if you put it in this function, it gives you what? 5, because you yourself reverse engineered that and found this number. So now my question for you is that if someone asks you, do you know, Babak, exactly this number? I would say no. But do I know this number exactly?
Yes.
What is the answer? No. Look at the graph. So if I ask you what is 2 to power 2, what is the answer? You go in this direction and find 4.
5.
And now the answer is
5.
5. So is that understandable? So you see, when I want to define this symbol for you, I start from the graph of which function? If I have logarithm of, for example, a to the base b, if I want to know it from graphical point of view, I should have access to which graph? Graph of which function? Can you see the analogy? I want to talk in general. If you see this symbol and you want to understand the meaning of this symbol, you need to have a graph at the graphical level. What graph? Graph of which function? No, compare it. When you wanted to talk about this log, which graph you were interested in? something to power x. What is that something?
2.
2. 2 is coming here. So in this case, what should I write?
Y is equal to a to the power
Y is equal to what?
8 to the power
No, be careful.
b to the power x.
Yeah, do you understand what you're saying or not? B to the power of x, yes? Because here, if you want to answer a question regarding this, you started with the graph of 2 to the power of x. If you want to say something about this, you should start with which graph? B to the x. Let us say this is your graph for the time being. Okay? Can you tell me, if I want to give you rulers and everything that you can measure, how can you show me this number on this graph? You will tell me that I go on the vertical axis and find where A is. When I found A, how should I do that? I go horizontally. When I intersect this graph, I go vertically. This point is what? Logarithm of A to the base B. Understandable or not? So that is the meaning of logarithm. So this I want you to understand. And you can play around with different bases. You know, here I started with x to power 2, then I changed to x to power 3. I can play the same game here. I started with 2 to the power of x. I can start with 3 to power x, 5 to power x, any number, and then do this engineering, yes? So let us try to understand this a little bit better. Okay, so let me ask you another question. For example, you want to show me logarithm of, let us say, 4 to the base 7. I want you to understand it graphically. So what should we do? Which graph I need to understand about this number? Yes? So I start setting up my coordinate system.
Y equals to 7 to the power of x.
Yes, this base will also be the new base. Yes, so it becomes y equals to 7 to the x. You draw the graph of 7 to the x. What is this length again? It's still it is 1. Why? Because if I put x equal to 0, even in this new function, 7 to the power of 0 is still 1. So that is still 1. Okay, but now can you show me where this point lies? What should I do here? I know I need to go to the vertical axis, find which number? 4. So let us say here is 4. And then what? I go horizontally, I find the intersection, and go vertically. Then I will cut the x-axis at some point. This point is a number. What number is that? It is very strange. Log of which number? 4 to which base? 7. Okay? If I ask you more than that, if I ask you what is the meaning of this, you can answer it in the same way. Either approximately, use your calculator, it gives you a number, or mathematically. Mathematically is important for me because calculator, so you can use your calculator and find a number. I will tell you how. Okay? But then if I want to tell you what is this number, how do you define it mathematically? You would say logarithm of 4 to the base 7 is the only number so that
4 to the power of that number becomes 7.
no,
7
7 to the power of that number becomes 4. Because this graph is graph of 7 to something. You see, this point given to this function will give me 4. Because usually, this is a little bit hard for you to understand because usually we go vertically up and then go horizontally. Yes, because our goal was to find the output. But here we do it the other way around. I am asking which input gives rise to 4. Okay, so this is why we go backward. But this is the only number so that 7 to that power becomes 4. Yes or no? Agree? Okay. But I will make it simpler for you. But I want to understand it from graphical point of view first. Okay, let me now ask you. If A is positive, B, I will talk a little bit about them, and B is positive and B is not equal to 1. That is extremely important to remember. then I am allowed to talk about this symbol. I am allowed to write this. Do you remember? I am not allowed to write a square root and minus 5 there. There are some rules that I have to respect. Of course, this is not a God-given rule. Why this is not allowed to write square root of minus 5? Because the square root of minus 5 is supposed to give me the number whose second power is minus 5. But there are no second number to its power is 5. So this is not defined at all. So there are some rules that I have to respect. When it comes to a square root with even root, there's only one thing that I have to be careful. I am not allowed to put negative number there. But when it comes to logarithm, because I have two numbers involved, each one of them has a separate condition. The one sitting in front is not allowed to be negative. You will see why. Why there is no allowed to be negative? For example, let us choose minus 4. And I want to do the same process. I go horizontally. It doesn't matter how I go. I will not the intersection. I will not have the intersection point.
There's no number to anything.
Negative, yes. That's exactly. So this is why A has to be positive. But the reason that B should be positive and B shouldn't be equal to 1, I will talk about that a little bit later. About that B is not equal to 1, I can immediately tell you why. Because if B is 1, I have the function 1 to power x. But what is 1 to power x? It is just 1. So if I ask to draw the graph of y equals to 1 to the power of x, it will not become a curve. It becomes what? A straight line. Okay? And then I don't have any answers. Yes, for example, if I give you this, when I go horizontally, I will not have intersection points. So this is why you understand that A should be positive, otherwise I'm in trouble. You understand that B shouldn't be equal to 1, otherwise I'm in trouble. Yes? But the reason that B should be positive, I talk a little bit about that later. But you have to respect 3 conditions, otherwise you're not allowed even to write such a symbol. Okay? Then when you write this symbol, what is the meaning of this? I want you to write this in your notebook. This is logarithm of A to the B is the only number such that if B is raised to that power, the answer becomes A. It's a little bit convoluted, but you have to get used to it. I think this is the best way to write it in your notebook. Logarithm of A to the base B, you need to read it in this way. Logarithm of A to the base B under these conditions is the only number such that if B is raised to that power, the answer becomes A. Yes, but I can make it much simpler for you. For example, can you tell, I would write that logarithm. Let me give a very simple example of 100. So let me write 64. Okay, to the base to the base 8. First of all, am I allowed to write something like this?
Yes.
Yes. Why? Because this number is positive. This number is also positive, but also not 1. So I'm on the safe side to write this symbol. But what is the meaning of the symbol? It is asking you, give me a number so that when 8 raises to that power, it becomes 64. Sometimes you can do it in your head, sometimes you can't, you have to use a calculator. In this case, you can. What is the question mark? 2. So logarithm of 64 to the base 8, is 2. Why? Since 8 to power 2 is 64. Yes? For example, can you tell me what is the logarithm of 5 to the same base 5. It is asking you, tell me a number so that this number, whatever it is, raised to that number that you're supposed to answer becomes this number. So that is the question mark is 1, since 5 to power 1 is 5. Yes or no?
Yes.
Okay, for example, logarithm of, can you answer this question? 1 over 4 to the base 2. Okay, look. First of all, am I allowed to write such a thing? Yes, because 1 over 4, which is playing the role of A, is positive. 2, which is the role of B, playing the role of B, is positive and not equal to 1. So I am on the safe side. That is acceptable to write such a thing. But what is this number? It is asking you, give me a number so that when I raise 2 to that number, it becomes 1 over 4. If you can do it on top of your head, just write the answer. If not, write it as x. You are looking for x. Then it means what? It means 2 to the power of x is equal to what? 1 over 4. If you can guess, guess. Otherwise, you have to continue. Let us say I cannot guess. So what should I do? I go forward. Instead of 4, I write what? 2 to the power of 2. Then from Math 1C, I learned that 1 over 2 to the power of positive 2 can be written as 2 to the power of minus 2. Now it is not hard to guess at all. 2 to some power, which I don't know, is equal to 2 to the power of minus 2. So what x is? What is x? Minus 2. So the answer is minus 2. Yes? Okay. Any questions here? Okay, let me make the question a little bit harder. So today we want to calculate only those ones that we can calculate without calculator. With calculator, I will tell you how to do it. You just punch some keys and the answer pops out, yes? So now let me make the question a little bit harder. For example, what happens for logarithm of, not very harder, but let us just do that. These are simple ones. Logarithm of 100 to the base 10. It's very simple. No, it is asking you to give me a number so that 10 to that power becomes 100. So what's the question mark? 2. This is a convention like the third sign. If I write the third without this number on top, it is always 2. And this is very common that if you don't see this 10, if the base is 10, you don't write it down. So you just simply write log of 100. When you see log of 100 and this number below is not written, you have to assume that this is 10. Okay? And I don't know, in Swedish book, for a strange reason, they show it with LG. So I will not use that. So in the book you see LG, they mean logarithm to the base 10. It is not common at all. I haven't seen that in any other places. Okay? So I will stick to my English way of writing. So if you see LG in your book, it means the base is 10. But I just write LOG without any base, it means it is base 10. Yes? So if I want to write logarithm of 100 to the base 10, I simply write log of 100. In your book, they write LG 100. Yes? Yeah.
Is that when it's only 100 or?
No. If only for example, I can write logarithm of 1000. Can you answer me what is this number? 3. Because it is asking you, give me a number so that this number that you don't see, but when you don't see, what is that? 10. To the power of question mark becomes 1000. So what the question mark is? 3. Yes? So logarithm of 100, from now on, I will write it as logarithm of 100. So it is 2. Logarithm of 1000 is what? 3. Can you tell me what is logarithm of 0.01?
-3.
Minus 2. Why is that? since which number, which is not written here, 10, to the power of minus 2 is what? Is equal to 1 over 1 to the 10 to the power of 2, but then it means 1 over 100. 1 over 100 is 0.01. So that is it. I'm not saying that, I mean, it's not hard at all. You first of all, you have to get used to this way of thinking, but the hard problems will come in the future, but these are not hard. Yes? Understandable or not? Okay, so if I say, what is logarithm of minus 2 to the base 3? What do you say? Undefined. Because this is negative. If I write logarithm of 1 to the base 5, sorry, 5 to the base 1, what do you say? Undefined again. Yes? And then I can also write logarithm of 7 to the base minus 2. What's the answer? Undefined. Yes, good. So you have to be careful. The person who writes logarithm, that person should respect all the conditions. The number in front should be positive. The number below should be positive and not equal to 1. If you see something that person is violating the rule. So these are not actually correct. Okay, so can you tell me what is the answer to this? So logarithm of the third root of 2 to the base 2. It is asking you about a number so that 2 to that number becomes the third root. So the question mark, 2 to the question mark should be the third root of 2.
1/3.
Yes, because from Math 1C, you know another way of writing this is what? 2 to the power of 1/3. So 2 to the power of question mark is 2 to the power of 1/3. So it is very easy to understand that this one is 1/3. So many of them does not need any calculator. So you should be able to do that. Yes? Okay. Okay, now I want to give you a little bit of harder exercises. Okay, can you tell me what is this one? Is this true or false? So is this a statement that I have written here is true or false?
True.
So how should we know that?
Because
If you want to check this is true or false, there is only one way to check it. How do you check it?
4 to the power.
You need to ask yourself, is it true that 4 to the power of 1 comma 5 is equal to 8? If the answer to this is yes, then this is true. If the answer to this is false, yes. If the answer to this is no, this is false.
True.
So which one is that?
True.
How do you know that?
Because 4
Because 4 to the power of 1 comma 5 can be written as
square root of 4 to the power of 3. No, square root of 4 times itself 3 times. No?
I don't understand what you're saying.
Square root of 4, then you
The
take
square root of 4, I don't have a square root of 4 here.
I know, but to know that you can do the square root of 4, which is 2, and then you can multiply 2 by itself 3 times.
Okay, but this is a little bit convoluted way of logic. Yes, yes.
Can't you write it as 3 over 2 instead?
Yes, but then what is this helpful then? I don't know, might be, I'm not saying these are wrong, but these are a little bit weird logic. I would prefer to write 2 to the power of 2 for 4, and then to the power of 1 comma 5. And then 2 times this one is what? 3, and then it becomes 8. So that is true. Yes? Okay, so what do you think about this one? Logarithm of 1 over 27 to the base 3.
Minus 3.
What?
Minus 3.
So you are claiming that, for example, if you can guess, yes, your answer is correct. Minus 3 is correct. But if you cannot guess, how do you solve? You say that, okay, I want to solve this, but I cannot guess. I call it myself x and try to find x. If you write it x, what does it mean? It means 3 to the power of x is equal to 1 over 27. If you can guess at this stage, you are done. If you cannot, you can continue a little bit more. So what can I write for 27? 3 to the power of 3. Then I bring it up, it becomes 3 to the power of minus 3. So look, I have 3 to the power of x equals to 3 to the power of minus 3. Comparing these two, I can immediately realize that what x is? Minus 3. And then you go back here and write minus 3. But if you can guess, it is better to guess. Okay, but sometimes you really cannot guess. For example, I write one thing, I want to wait for you. This is a hard question. So you need to tell me what is this number. So without calculator, the logarithm, let me see what I have written. The third root of 16, but the base is a weird number, 1 over the fourth root of 8. Okay, I want to wait for you. You remember this. If you have forgotten, let me write this here. There are two formulas that are important. The square root of the box can be written as box to power 1/2. And if I have the nth root of the box to power m, how should I write it as fraction power? I put my box here with a fraction on top. How should I manage the fraction? This goes where? This number that you see here always go to the denominator, and this number goes there. So I don't know. You need to know these formulas very good for this chapter.
Are they not on the formula sheet?
I think this one is not. This one is there with just a box. So then this is written as box to power 1 over n. But for m, you have an extra m there. Yes? So make sure that you understand them. Okay, I want to wait for you. This is a little bit hard problem, so be patient. I don't think there is a person who can guess this out of the blue. So call it x and try to find x. And when you're done, you can just tell me your answer. Okay, so if you go to GeoGebra, so what you can do it like this. I just type log. I think it is working. Yes. You see, there is a log to the base 10. So what are the other logs? So it should be a log. Yes, here. You just go log b and x. B is the base. So I click on it. So what is the base here in my problem? See, what is the base? Base is this number, and this is number in front of the log, but you have to get used to. The GeoGebra notation is different from the one that we write in the books. Okay, but you understand that. B is for the base. So I need to type the base here. So the base is 1 over, and then what do you see? The fourth root of 8. So do you remember how should I put the fourth root? I go to f of x in GeoGebra. There is this symbol here. I choose that one. The number on top is clicking now 4, and this number is 8. Then for x, I have to type in the number. So what is the number? The third root of 16. So I use this, and this is the third root, and I don't know why I have two boxes here. Yes, I don't know, 16. This box, I don't know. So unfortunately, it doesn't give you the exact value, which is a little bit strange to me. Okay. Might be we should go to cast view. That is exactly, you see, when you press enter, it types exactly as if it is in a book. That's a good sign. But if you don't mind, let me also copy and paste it to the cast view to see if I have the exact answer. Control A, Control C. I go here to view, cast view, and then I type it in cast view to see what the answer is, and then press enter. Oops. I understand what is it doing, but that is not a good idea. No, so probably GeoGebra is not good for calculating the numbers. Yes, this number is correct. I'm not saying it is wrong, but it's not very powerful when it comes to calculation of logarithms.
Baba, what about graph? When you look at
No, you can. No, I mean he answered us. It answered us minus 1.78. That is not wrong, but I wanted to find the exact value. The exact value, according to my calculations, if my calculation is correct, is minus 16 over 9. That is my answer in my notes. But let me check. Might be I made a mistake. Let us calculate. It's a hard problem, but it's still very doable if you follow the rules. Of course, it needs to remember Math 1C very well because you need to be able to work with powers. So there is no way that I can guess what this x is. I put it x and I use this. What can I say? I would say that if this is x, it means that this number, whatever it is, to this power is supposed to be equal to this number. So what should I write? I would write 1 over the fourth root of 8 to the power of x is equal to the third root of 16. Yes? And then still it is very hard to guess this number. So I have to start simplifying things so that I can immediately compare them. What is your suggestion?
I do it.
If you look at 8 and 16, they have some connection to power of which number? 2. This is important. So you write them in form of 2. So I would write 1 over the fourth root. Instead of 8, what do I write? 2 to the 3. And then to the power of x. Here I can write what? 16 is 2 to the power of 4. But you also have this formula. I have written it here for you. So I can get rid of the third signs using that fraction power formula. So what can I write here? So I would write 1 over, what can I write for this? I write 2, but what is the power? It's a fraction. How fill up the fraction? This number goes to the base, goes to the denominator. This number goes to the numerator. And then I have x there. Yes? And then what happens here? The same story. I put 2 and I put a fraction as a power. This number again goes here. This number goes there. Okay, this is so far, so yeah, I cannot continue the right hand side more, but there is something that I can still do with the left side. What is your suggestion? Yes, bring it up and make it negative. So what happens? It becomes 2 to the power of minus 3 over 4, and then to the power of x is equal to 2 to the power of 4 over. And there is another rule I hope that you remember from Math 1C. What can I do with these powers after powers? Multiply. So it becomes 2 to the power of minus 3 over 4 times x is equal to 2 to the power of. Now it is not hard to guess because I want to have equality. I see this number is the same number. In order to have the equality, there is only one way. What is that? To match, to force these match. Yes? So it means that minus 3 over 4x should be equal to 4 over 3. And this is an extremely simple problem to solve. I get rid of fractions first by multiplying by 12, for example. This becomes minus 9x, because when I multiply 12, 12 and 4 simplified, 3 is left, so it becomes 9. When I multiply 12 here, 12 and 3 are simplified, 4 is left, so it becomes 16. I am looking for x. So what is x? Yes? So this is the answer. And I'm sure that the answer given by GeoGebra first, it was correct. So if I go and type 16 over minus 16 over 9, that's exactly that number. But that's a little bit, I didn't expect. I expect that GeoGebra is able to give me the exact value. The exact value is minus 16 over 9. Minus 1.78 provided by GeoGebra is just an approximation. Yes, but it's a good approximation. So this is a hard problem. I mean, if you really understood what I did here, you totally understand more than necessary, more than enough for this level, because there are a lot of formulas coming in, but that is what it is. Any questions so far? Okay, let me ask your opinion about this problem. That's also a good problem. I want you to guess it for me without calculation at all. So this is the number I want you to calculate. So logarithm of 8 of logarithm of 4 of logarithm of 16. It's a very simple problem. You shouldn't be scared about. First of all, I want you to understand these consecutive logs. Yes? When it comes to the first log, you see 8 to the base. But if I ask you what is the number in front of it, the whole expression is sitting in front of it. Okay, but what is this log? This is a log to the base 4. The number sitting in front is this one. But this is, what is this log? This is a log to the base 2. The number sitting in front is simply 16. So now can you tell me what to do with this? What is the answer? Yes?
The first one, the log 2, log 16 to the base 2.
Yes, so you copy and paste the first one. You copy and paste the second one. But for this one, you can do it in your head. Do you agree, everyone? Logarithm of 16 to the base 2 is 4. So instead of this one, what do I write? 4. But what is logarithm of 4 to the base 4? 1. And then I get logarithm of 1 to the base 8.
Which is 0.
Which is 0. So that number is 0. Yes? Is that right? Logarithm of 16 to the base 2 is asking what is the number so that 2 to that number is 16? It is 4. So if this one is 4, what do I have? I have log of 4 to the base 4. It is asking me what is the number so that 4 to that number becomes 4? It's 1. So this number is 1. So it becomes logarithm of 1 to the base 8. So logarithm of 1 to the base 8 is asking me, giving a number so that 8 to that power becomes 1. And 0 is the only one. So 8 to power 0 is 1. Okay, understandable or not?
Yes.
Okay. One more question and I will stop. Okay, so what is this one? It's a little bit hard question again. So logarithm of the second root. Let me see what I have written. Second root of the fifth root of 10. Yes? This is the last question we solved.
So base is automatically 10.
Yes, yes, and that's good to remind. If I told you, if there is no base, it means the base is 10. Minus 1. So it means that you actually progressed a lot. So I don't know, how did you manage that? So the first thing is to understand the second root of the fifth root of 10. So what can you do here? You can write the second root, the 10th, this you can write it as this. But then this can be written as what? To the power of 1 over 2. But then it becomes 10 to the power of these two multiplied is 1 over 10. So now look, this is asking you logarithm of this number, but this number is 10 to the power of 1 over 10. Okay? Now, this base is what? 10. It is asking you 10 to which power becomes this number? What is that number? You see, let me ask you this question. Logarithm of 10 to the power 99. What is the answer? The base I haven't written, it is 10.
99.
It is asking you which number is that, so that 10 to that power becomes 10 to power 99.
99.
So it's 99. Yes? So now the same story. What is that number so that 10 to that number becomes 10 to power 1 over 10? It's 1 over 10. Yes? So it becomes 1 over 10. I have logarithm of 1 over 10. But again, it is asking me to which power 10 should be taken so that the answer becomes 1 over 10. What is that number? Minus 1. Yes?
This is
Yes. So logarithms are actually, when I was at your age, I was enjoying this because they are hard, but hard enough. Because if it is too hard, we cannot solve. But this is beautiful. I mean, you should be able to calculate these things. Yes?
Good.
Yes? What?
Yes. It's like an aha moment.
What?
No, nothing.
Okay. You don't see any beauty in these
I like the
calculations?
beauty. I like the beauty.
You like the beauty?
Yes, yes,
Yes.
very much.
But you should be. So where do you see the beauty then? Not in equations.
Like,
Yeah.
who knows?
Yeah, I can imagine at your age what you see beauty in. Yes. Yes. Anyway, any questions? Okay, we stop here.